Next, I am going to explain the reason of why I choose this documentary about swimming. In this case, it's because when I was a child, I liked too much swimming, and now I practice a little swimming, but I like this too much. Next, I am going to explain some basic rules in swimming. The first one is respect the starting order. The second one, movement dynamics. The third one, coordination according to the steps. Four is long arms so that the stroke is more extended. Five, you must fulfill all the medals of the corresponding competition. Six, test or competition outings can be in freestyle. Seven, the start in back and combiner relay test is done from the water. 8. Any swimmer who comes out before the exit signal is given will be disqualified. 9. The swim is freestyle. And 10. Any part of the swimmer body must touch the wall when completing each section. Next of this, I am going to give you one example of this. When you are in water, you can feel resistance. This is called hydrodynamic drag. It is effective force created by the interaction of your body and the water. Swimmer pushes against water to move forward, and water pushes back to slow them down. But the solution to this is that in this type of cases, the Olympic swimmers try to maximize useful drag and minimize burdenous drag. Let's start with physics in swimming. The physics in swimming have just four essential forces. These forces are the gravitational force or shear force, buoyancy force, thrust force, and the drag force. These forces, how I say, are essential for the swimmer in this case. The gravitational force is when it's a downward force that depends upon the swimmer mass. This put that swimmer going to down in the swim, the pool. The buoyancy force is this: when the water pushes up on the swimmer with a value proportional to the volume of water displaced by the swimmer. If the swimmer stays at the surface, buoyancy force must be equal in the magnitude to gravitational force. Another magnitude that we have in this case, that is swimming, is the thrust force. That is something that must push the swimmer forward to balance the drag force. In this case, the thrust is a combination of a swimmer kicking off the water with her feet and pulling it with her hands. And the last one force is the drag force that I'm going to explain as this. As the swimmer moves forward, he or she pushes the water. This water pushes back, producing drag force. The drag force depends upon the shape and size of the swimmer and his or her speed relative to the water. Good. Drag comes from thrust force. It is created by the swimmer's hand moving backward through the water and their kicking feet. It is amazing that this forward drag can be equal to the backward drag caused by the forward motion of the rest of the body. but it can. But the real question is how do you minimize the bad drag that here in this case? Um, I have the answer. The bad drag can be minimized with a formula that I'm going to explain first with your terms. The first is the density of the water, P, that is fixed variables unless you are swimming in something other than water. The second is the cross-sectional area, that be A, which is related to the underwater profile of the swimmer. Yes, you can alter this a bit by changing how you move your arms and rotate your head. That could lead to slight decreases in drag force. And the last term to consider is the drag coefficient, that be C. This is a variable that takes into account how water interacts with the object. It depends on the shape and the surface of that object. A raw brick will have a different drag coefficient than a smooth brick of the same size. A sphere will have a different coefficient than a cylinder. Decreasing drag coefficient even a little can make a difference. With a smaller coefficient, a swimmer can increase speed without increasing power output. In this case, the work done by the swimmer is equal to the drag force multiplied by the distance traveled, but if you take the distance traveled and divide it time, you get the swimmer's velocity. Mm, for the last one example, I'm going to give you one example that be in this case with these measures. In this case, I'm going to put a 1% decrease in the drag coefficient that will produce a 0.34% increase in speed. That's a good example. Um, One USA swimmer, Katie Ledecky, is in a 40,000 meter freestyle. Your own record wall is that one time of 236.46 seconds for an average speed of 1.6916 meters per second. If she were able to produce the same power but with 1% decrease in the drag coefficient, she would have an average of speed of 1.6957 meters per second with a time of 235.89 seconds. What do you think that is the relationship between swimming and physics, or what do you think about physics that is relationship with swimming?
Pues yo creo que sí hay mucha relación, ya que cuando entrenas o practicas la natación, te ponen unas paletas para mejorar la brazada y que la brazada entre en este sentido y que cortes el agua, que vayas cortando el agua para que te dé mayor avance.
Another type of relationship that you found in this sport?
Ah, sí, para mí se me hace muy divertido el practicar y, y aparte pues es un deporte en todo el sentido y mueves todo tu cuerpo.
Have another physics in this sport, uh, also the brazada.
No te entendí.
The relationship between physics have another, or it's only the brazada?
Ah, pues sí tiene que ver mucho la abrazada y también la patada, ¿no? O sea, la abrazada pues es lo que te va a dar el impulso para avanzar, para ir con rapidez y pues la patada es la que también te da la velocidad.
It's only this.
Sí, sería todo.
Okay, thank you.